the data we're working with is not really interval or ratio data. It's not even really like ordinal data, right? When
Yeah.
it comes so how, I know there's like an art and a science to it, but like how do you come up with the benchmarks? And just so listeners have context, right? Like for
Yeah.
something like change lead time, the
Yep.
survey options are ranges, like
Yep.
between once per week and several times a week. So to then turn that into like a hard number, how do you deal with that challenge?
Yeah. Thankfully, we're not the first ones to have to deal with it. So, unlike maybe some things that are very developer specific, there's a good literature on how would you work with maybe ordinal. Definitely not. There's no ratio here. That's for sure. How do you work with this type of data in a context where you really want to pretend it's a number? And it's just not. You know it's not a number, but you're trying your best to treat it like such. So I know within the structural equation modeling world, you can pick your estimators that you want to use. These are pretty much how the data gets optimized. There are some that work way better with this type of data than others, right? And so once you get it through that process, there's some literature that suggests once the actual factor score, which is that latent score from the multiple indicators, now we're really diving into the weed, it can be treated as a continuous number. But that still doesn't get at your question because change fail rate or something along those lines, deployment time, deployment frequency, those are still just scale. Those are just survey items. And my approach has always just been, how sensitive is our answer to our method? And by that, I simply mean if I try 4 different ways of clustering this data together, do I get 4 wildly different answers? And if I do, then it's too up to me to really talk about, right? So you can sort of talk about researcher degrees of freedom. And if I feel like the answer depends on what I choose, it's probably not a good answer, kind of thing. But if it's not super sensitive to what I choose, right? So I try 4 methods, 3 out of 4, the answer looks almost identical, and the fourth one's a little aberrant. I feel a lot more comfortable than when all 4 of those methods look completely different. So that's my approach. It's not perfect. There's still an underlying problem of the data type and the analysis that you need to work through. But I think at the end of the day, you try your best to make your analysis fit with the type of data you have. And where it's questionable, you try 3 or 4 different other approaches. And if it doesn't look like it's super sensitive to your mood that day, then it's probably a pretty good answer. Another thing we've been looking at is latent class analysis, I believe it's called. And that's more of dealing with nominal data, clustering nominal data. So everyone's trying a different way of doing it. So I try to do as many of those ways as I can and see how different the answer looks.